In the late 17th century, Sir Isaac Newton formulated three fundamental laws that would revolutionize our understanding of motion and physical interactions. These laws form the foundation of classical mechanics and explain how objects move in our everyday world. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction, unless acted upon by an external force. Look at this ball sitting still on the ground. Without any force applied, it remains motionless. But when we apply a force, it begins to move. Once in motion, it would continue moving forever if no other forces, like friction or gravity, acted upon it. This explains why you feel a jerk when a car suddenly stops or starts. Your body wants to maintain its current state of motion, demonstrating inertia. Newton's second law quantifies the relationship between force, mass, and acceleration. It states that force equals mass times acceleration, or F equals ma. This means that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. Let's apply the same force to two different objects, a small mass and a large mass. The small mass accelerates more quickly, while the large mass moves more slowly. This is why pushing a shopping cart is easier than pushing a car with the same force. Newton's third law tells us that for every action, there is an equal and opposite reaction. When one object exerts a force on another, the second object exerts an equal force in the opposite direction on the first. These two squares demonstrate this principle. When the red square pushes on the blue square simultaneously pushes back with equal force in the opposite direction. A perfect example of this law is rocket propulsion. As the rocket expels gas downward, the gas pushes the rocket upward with an equal force, allowing it to lift off from the ground and soar into space. Together, these three laws, the law of inertia, F equals ma, and the law of action and reaction, form the cornerstone of classical mechanics. They explain everything from why we need seatbelts in cars to how rockets can escape Earth's gravity. Newton's insights continue to be essential in science, engineering, and our everyday understanding of the physical world around us.